Hello there guys, welcome back to another epic and extrable maths video. In this video, we're once again looking at the t-formulae or the tangent half angle formulae. Okay, so we already have quite a few videos on this on the channel, so I will leave the link in the description to the playlist on the rest of the t-formulae videos. But here we have another example. So we want to solve the equation 16 cot x minus 9 tan x equals 0 for x between 0 and 2 pi. And all of the t-formulae are written there in terms of theta, but of course it's the same for x. It doesn't matter what symbol that we use. So let's just go straight in and have a go at this. So first things first, let's replace the trig functions with what they are in terms of t. So cot is 1 over tan, so I can replace cot with the reciprocal of tan theta, so 1 minus t squared over 2t. And I can replace tan x with just 2t over 1 minus t squared. And that's still equal to 0. So now we have an algebraic equation that we can solve in terms of t. So we just have to rearrange this. So maybe let's just, let's times everything by 2t to begin with. So we'll have 16 times 1 minus t squared minus 9 times, and this term is times by 2t, so 4t squared up here. And then that's still equal to 0. Let's also multiply everything by 1 minus t squared, I think. That's probably the best thing to do. So 16 times 1 minus t squared squared minus 9 times 4t squared still equals 0. And then let's just expand this all out. So we have 16, and then 1 minus t squared squared would be 1 minus 2t squared plus t to the power of 4. And then 9 times 4 is 36, so minus 36 t squared equals 0. Okay, continuing to expand this out, we have 16 minus 32t squared plus 16 t to the power of 4 minus 36t squared equals 0. And then what else can we do from here? Well, we can simplify it ever so slightly. So let's rewrite 16t to the 4, and then we have minus 32t squared minus 36t squared. That's minus 68t squared, and then there's still a plus 16 there. So plus 16 equals 0. Okay, then we can divide everything by, what can we divide everything by? We can divide everything by 4. Okay, so if we divide everything by 4, then we will have 4t to the 4 minus, and then what will 68 divided by 4 be? Well, let's think about that. 68 divided by 4 is going to be 17, so minus 17t squared plus 4 equals 0. And we can't divide any more because 17 is a prime number, it doesn't have any factors. And so what we can do, and also by the way, it's a quartic equation because we have a t to the 4. Is that an issue? Well, actually, no, it's not, because this is a quadratic in disguise, guys, okay? So it depends on how much detail you need to go into for this. But what I'm going to do is I'm going to come up here and I'm going to say, I'm going to make up a new letter, let u equal t squared, okay? The reason I've done that is now I can write this down here as 4u squared minus 17u plus 4 equals 0, okay? And then I can solve it like a quadratic, okay? So that means that u would be, and I'm just going to use the quadratic formula, I think that's potentially the easiest way. Or actually, you know what? Let's factorize it. Why not? Because I think this is going to factorize nicely, okay? Because we need two numbers at times to make 16 and add to make minus 17. Well, what about minus 16 and minus 1? Yes. So 4u squared minus 16u minus u plus 4 equals 0. Okay, and then we can rewrite this as 4u times u minus 4 equals 0, and we need to put a minus there in order for that to work. So that means that it's factorizing to 4u minus 1 times u minus 4 equals 0. So that means that u would be equal to a quarter, or u would be equal to 4. Okay? Now we said that u was t squared, so t squared is a quarter, or t squared is 4. And that means that t on its own, tan of, I guess it's actually going to be tan of x over 2 in this case, would be plus or minus the square root of all of these. So tan x over 2 could be a half, minus a half, 2, or minus 2, because all of those numbers, a half and minus a half square to make a quarter, and 2 and minus 2 square to make 4. So these are our values of tan x over 2, and now we're back into the trig world. We can try and solve this. So I'm going to cut, and we're going to go and solve this. Okay guys, so we have 4 different equations here. Again, tan x over 2 is a half, tan x over 2 is minus half, tan x over 2 is 2, tan x over 2 is minus 2. And we can individually solve all 4 of these for values of x between 0 and 2 pi. So starting with the first one, taking inverse tan of both sides, we would have the inverse tan of a half, arctan of a half, is 0.4636, roughly. Okay, that's the first value of x over 2. Again, we're going to double that later, and with tan, solutions to equations involving tan, you can add pi to your answer and it will still be a valid answer. However, do you see that if we were to add pi to this, when we double it, when we times this by 2, we'll have a positive number plus 2 pi, so it won't be in the interval. So basically, in this question, every time we get a positive number, we don't need to add anything to it because it won't be in the interval. Okay, next, inverse tan of minus a half. Inverse tan of minus a half is just going to be the same number but negative. So inverse tan of minus half is just going to give us that x over 2 is minus 0.4636. And for this one, we also can add pi to it, and that will be fine because at the moment this isn't an answer, right? So we actually need to add pi in order for it to be an answer. So normally it would be minus 0.4636 and minus 0.4636 plus pi, but this one isn't an answer anyway, so I'm just going to write that as the answer. Okay, next one, inverse tan of 2. Let's see what that is. Inverse tan of 2 is 1.1071, okay? And again, no need to add pi to that. And finally, inverse tan of minus 2 would give us the same thing but negative, minus 1.1071, etc. Okay, and again, same logic as the second one, we're going to need to add pi to this in order for it to be in the interval. These will be the only solutions. So now I'm going to go back through the answers and I'm going to double them. So my first answer will be that x is equal to 0.9272. That's my first answer. That's the top one doubled. The next one, I've got minus 0.4636 plus pi, and then I'm doubling that. So I'm just doubling the second one to get x on its own there. So this second answer would be x equals 5.356, roughly. Okay. The third one, 1.1071 times 2. Okay, and I'll write it here. The third answer, we get x equals 2.2142. And finally, the very last one, we have minus 1.1071 plus pi, and then we're doubling that one. And so the last answer is 4.0690, or 4.069. to about 4 decimal places there. So I've written them all to like kind of different numbers of decimal places. Of course, it doesn't really matter too much, but these 4 answers would be the only answers. And as always, we should check to see whether pi is an answer, because as I've said in every video on the t-formulae, if pi is an answer for x or theta, we won't get it, okay? Because of the nature of the fact that we're doing tan of theta over 2. If theta or x was pi or 3 pi or 5 pi, there's an asymptote there on the function, so it's not going to be defined, it's a discontinuity. So just by looking at this function, will pi be an answer? Well, no. The reason why is because tan of pi is 0, and cot is 1 over tan. So 1 over tan of pi is undefined. Okay, so we know that pi is an answer, so these 4 values are our only answers. As always, guys, thank you so much for watching. I highly appreciate it, and I will see you in the next epic and extra maths video. Cheers.